Alright guys, so in 913, all we're really doing is a recap of the properties of kites and trapezoids. So if we want to just go ahead and label our notes as 913, kites and trapezoids review, you can. And all you guys need is a piece of paper and something to write with. First one we're going to talk about is the non-isosceles trapezoid. And again, this is a recap, so you guys should have all of this somewhere already. Non-isosceles trapezoid. Don't forget when you guys are labeling your quadrilaterals that you need to label them clockwise. So I'm going A, B, C, and D. So this is a non-isosceles trapezoid. There are only two properties associated with non-isosceles trapezoids. The first is that there are one pair of opposite sides that are parallel. And in the example that I've drawn, those pair of opposite sides would be sides AB and DC. We call those we call those parallel sides the bases of the trapezoid. So I guess we could get a little bit more specific and just say that AB and DC are bases. The second property is that the consecutive angles are supplementary. So let's see. So it's going to be angle A plus angle D is equal to 180 degrees, and angle B plus angle C is equal to 180 degrees. So these two would add to equal 180. So with the consecutive angles, you guys are more so looking at an angle from each base. So angle A is an angle from this base up here. If you add it to angle D, which is from this base down here, then those are going to add to equal 180 degrees. So it does not work for the angles along the same base. It has to be an angle from each base. Those ones are going to be the supplementary angles in the non-isosceles trapezoid. So the non-isosceles trapezoid only has two properties. The isosceles trapezoid, which is what we're going to do next, has these two properties. So it still does have the same properties of a non-isosceles trapezoid with the addition of a few more. So the next one we'll just put as that the legs are congruent. The legs are referred to as the non-parallel sides. So we'll go ahead and do our best to draw an isosceles trapezoid. Looks more like this. It's not perfect, but that's okay. So again, make sure we label it going clockwise, A, B, C, and D. So the legs are congruent. Your legs would be legs AD and BC. So we'll put AD is congruent to BC. Next property is that the base angles are congruent. Base angles are congruent. There are going to be two sets of base angles. So you have one set being down here, so angle A is congruent to angle D is congruent to angle C, and then angle A is congruent to angle B. So those are like, here's one set of base angles, here's your other set of base angles. So we'll say angle A is congruent to angle B, and angle D is congruent to angle C. Next property is that the opposite angles are supplementary. So opposite angles are supplementary. You're still going to have the consecutive angles here. So A and D are going to be supplementary to each other, but also now, because it's an isosceles trapezoid, D and B are going to be congruent. Supplementary. A and C will also be supplementary to each other. So angle A plus angle C is equal to 180. And then angle D plus angle B is equal to 180. The last property of an isosceles trapezoid is that the diagonals are congruent. So if we drew them in there, we draw diagonal AC, diagonal DB, those would be congruent to each other. So AC is congruent to DB. And I guess we can also add into our picture, these two would be your bases, your parallel sides. You guys have your congruent legs. Last concept we're going to address is the mid-segment of a trapezoid. So I'm going to do a different color down here. Let's change it to green. So if we wanted to find the mid-segment of a trapezoid, and it doesn't matter if it's an isosceles trapezoid or a non-isosceles trapezoid, there is a formula involved. To find the mid-segment, I guess we'll put the mid-segment is equal to your two bases. So base 1, base 2 divided by 2. It does not matter which one you guys label as your base 1 or base 2. But if we had like a visual down here, here would be a base, here's your other base. If we wanted to know the length of this mid-segment here, which is going to be in the very middle of your trapezoid, so that if it's in the very middle, then this piece of the leg would be congruent to this piece of the leg. These ones would also be congruent to each other. So if we wanted the length of that mid-segment there, we would add those bases and divide by 2. Okay, and then on the back, if you guys want to flip over, we can write down the properties of a kite. Maybe not the best at drawing kites, but you guys can turn your paper and draw a kite. A kite's going to have 3 properties. First, let's just go ahead and label our kite. So I'm going to go A, B, C, and D. The first property of a kite is that there are 2 pairs of consecutive congruent sides. So 2 pairs of consecutive congruent sides. So those, based on our example that we drew, you're going to have AB congruent to AD. That's 1 pair of consecutive sides. Your other pair of consecutive sides would be BC and DC. So we'll just kind of make a statement that AB is congruent to AD and BC is congruent to DC. The other property of a kite would be that there is 1 pair of congruent opposite angles. Those congruent opposite angles are always going to be the angles that are in between the non-congruent sides. So here would be non-congruent sides here. So angle B is going to be congruent to angle D. So those angles will always be in between those non-congruent sides. Last property is that the diagonals are perpendicular. Here's our symbol for perpendicular. So if we drew in diagonals, you would have diagonal BD and diagonal AC. All 4 of these angles here would be right angles because those 2 diagonals are perpendicular. So just say that BD is perpendicular to AC. And that is your recap of trapezoids and kites.